I'd like to welcome our first speaker, Ralph Gaume, and thank him for providing the opening talk to this conference. Ralph is the director of the Division of Astronomical Sciences at the NSF. He spent 7 years at the Naval Research Lab and 20 years at the U.S. Naval Observatory, where he worked on a wide range of astrophysical problems with a particular emphasis on radio astronomy. He's been at the NSF for a number of years in the Division of Astronomical Sciences, where again, he now serves as director. We're very pleased to have him opening up our conference, and I'll hand it over to you, Ralph. Thank you.
Okay, so yeah, as Nicole said, my name is Ralph Gaume, and I'm the Division Director of the NSF Division of Astronomical Sciences. And NSF enables multi-messenger astronomy through both our facilities and our grants programs. So let me go a little bit through what facilities we offer. Of course, LIGO is an NSF program that NSF has been supporting for a multiple number of decades, for quite a long time. And of course, everybody's familiar with these graphics. This is the first gravitational wave detection, GW150914. And the two NSF LIGO facilities, as you can see from the map, are at Hanford Observatory and Livingston Observatory. But it's not just LIGO, as you can see here, that can queue, LIGO can queue other observatories. So this is the LIGO detection in 2017 of GW170817, the gravitational wave detection of binary neutron stars, which triggered Fermi integral and also Blanco detection at the bottom from our Blanco telescope using the DE-CAM imager. In addition to gravitational waves, we also operate the IceCube neutron detector at the South Pole, and a very interesting detection of neutrinos, or neutrino detector rather, was in 2017. And this neutrino detection was tied to a flaring blazar, TXS 0506056, which turns out to be one of the most luminous sources in the known universe, and provided evidence, multi-messenger evidence, of a cosmic engine powerful enough to accelerate high energy cosmic rays and to produce the associated neutrinos. So that's at the South Pole. Our specific facilities that belong to my division, NSF Astronomical Sciences Division, are here on the map. At radio wavelengths, we operate the Green Bank, own and operate the Green Bank Observatory, Arecibo Observatory, the VLBA, and ALMA Observatory. And then in the optical, we own the Gemini Observatory, Kitt Peak Observatory, Saratololo, and one of our new facilities will be the Rubin Observatory, which will be coming online. In order to coordinate all of our ground-based optical facilities, NSF has recently formed the NOIR Lab, which is NSF's National Optical Infrared Astronomy Research Laboratory, and that will help coordinate our new flagship, as I mentioned, the Rubin Observatory, which will have a major impact on the dynamical universe and multi-messenger astrophysics through discovery of about 10 million transient events per night. So NOIR Lab will help to coordinate all of our ground-based facilities to follow up on these multi-messenger events. In terms of multi-messenger, we're also bringing on a solar observatory, and you may have seen this particular image, the first light image from our Daniel K. Inouye Solar Telescope back in February, made the front page of the New York Times. This turned out to be the highest resolution ground-based image or space-based image of the sun's surface ever produced. So now you're saying, why or how is this multi-messenger? Because normally we think of multi-messenger events as being from great distances out in the universe. However, DKIST will of course be part of a multi-messenger constellation in cooperation with NASA. The Parker Solar Probe will sample in situ particles and fields, and the European Space Agency's Solar Orbiter will also be sampling solar particles and fields, and this will be combined with the electromagnetic radiation which is received by the Daniel K. Inouye Solar Telescope on the ground. So we can think of these nearby multi-messenger events or the more remote multi-messenger events. So those are some of the facilities I wanted to quickly highlight. In addition, NSF enables multi-messenger astronomy through our individual investigator grants. You may have heard of our 10 big ideas, which are quickly all here in one chart. Well, one of these big ideas is Windows on the Universe, the era of multi-messenger astrophysics. Windows on the Universe goal is to build the capabilities and accelerate the synergy and interoperability between electromagnetic waves, high energy particles, and gravitational waves, focusing on theoretical, computational, and observational activities, and building dedicated experiments and exploiting our current facilities, which I mentioned before, and our next generation observatories such as Rubin Observatory. The first year for executing Windows on the Universe at the National Science Foundation was last fiscal year, FY19, fiscal year 19. We posted a program description, which you can Google if you want to see how this works. Google Windows on the Universe multi-messenger astrophysics. And this is a collaboration between my division, Astronomical Sciences Division, the Physics Division, and the Office of Polar Program. Last year in FY 2019, we received $147 million in proposals from a little over 200 proposals. We spun up an interdivisional implementation group, and we had $30 million of stewardship funding, plus another $33 million of divisional funding co-awards were made in 2019 to a total of 66 projects. So it's a total of a bit over $60 million to 66 projects. Looking toward the future, we of course are undertaking as a community now Astro 2020, our decadal survey, and NSF looks forward to supporting multi-messenger astronomy through the decadal survey. And we believe, although the decadal survey is maybe 10 months or so out, we believe that NSF will be able to support multi-messenger astronomy through the decadal survey's recommendation of large ground-based programs such as NGVLA, USELT, IceCube, Gen 2, and Advanced LIGO. Finally, I just wanted to put a plug in for NSF branding in order to support the next generation of all of our facilities. We really need to get the word out, not only to the public, but to Congress and to the executive branch of our government. So please highlight NSF's involvement in your science. Thank you.
Thank you so much, Ralph. I appreciate that. So we have time for just a couple of minutes for a couple of short questions. One thing I wanted to note was Brian Gensler pointed out in the chat that the sun was the first ever multi-messenger object.
Excellent.
Yes, definitely. I was wondering if you would be willing, it may be a bit trite, but would you be willing to say your thoughts on with the pandemic, what is the state of the NSF now and going forward in the next year? Would you be able to comment shortly on that?
Sure, just very briefly, some of our facilities are operating now. Some of them are not operating. Our Daniel K. Inouye, our major construction projects in terms of facilities are beginning to go forward in the Northern Hemisphere. Our construction for DKIST is continuing. It's on hold for Reuben. Our grants programs, we're continuing to allow um, salary funding through our grants programs, and we're looking to future congressional action to help us to help the university community through the impacts of COVID.
Thank you. And one question from an anonymous attendee was just if you could comment on NSF's plans for involvement in LISA or LISA-like projects in any way.
Yeah, that's more a NASA program or question for Lisa. And in that it's a space program, we'll certainly support theoretical modeling or programs that involve multiple of ground-based and space-based. But LISA is primarily a NASA issue.
Excellent. Thank you so much, Ralph, for being willing to talk with us today and be here.